Reactions of benzene or arene, Friedel-Crafts acylation and nitration. So arenes or aromatic compounds, the compound that contain benzene. The benzene ring has a high electron density. This is because of the pi the delocalized ring of electrons. So we have the pi delocalized ring of electrons in the benzene ring, which makes it very rich in electron density. So it doesn't undergo any addition reaction because addition reaction means we need to break the ring of the delocalized electrons. The benzene ring is highly stable, so it doesn't undergo this type of reaction, but instead they can undergo electrophilic substitution reaction where we have an electrophile. The electrophile is something that has a positive charge, and the electrophile can be attacked by the electron-rich benzene ring. In this reaction, one hydrogen from the benzene ring is going to be substituted by the electrophile. So the first reaction, electrophilic substitution reaction, is called the Friedel-Crafts acylation. In Friedel-Crafts acylation, an acyl group is added to the ring of the benzene to form phenyl ketone. And the acyl group is the group that has a carbon with a double bond O. And then this is added to benzene ring. And the end product of this reaction is the production of phenyl ketones, where you have this acyl group added and you end up with a ketone, with a phenyl ring or with a benzene ring. Once the group is added, then this group can then be modified by other reactions and then can make different compounds because the benzene ring itself is highly stable, so it doesn't undergo many different reactions. The reaction needs a strong electrophile with a positive charge, and in order to create an acyl group with a positive charge, we need a catalyst. And this catalyst is called a hydrogen carrier. This catalyst is used to make an acyl group with a positive charge. So you need to make an acyl group with a positive charge so it can undergo the electrophilic attack on the benzene ring. Aluminium chloride is this hydrogen carrier which is used in this reaction. It's called the Friedel-Crafts acylation catalyst. And the reaction condition is that we heat the reactants, which are going to be the benzene ring or the arene, with the acyl chloride, and then the in presence of the catalyst, which is the Friedel-Crafts catalyst, which is the aluminum chloride. And then we use non-aqueous solvent like diethyl ether. The end products are going to be a ketone and hydrogen chloride, where there is a substitution of one of the hydrogens from the benzene ring with this acyl group. So this is going to be substituted. So let's have a look at the mechanism of the reaction. There are three steps for the mechanism. The first step is the generation of the carbocation or generation of the electrophile. So we have the acyl chloride that we start off with, and we have aluminum chloride. Then the aluminum chloride, the electron pair on the chloride will be attracted toward the aluminum, and that will generate the acylum ion with a positive charge. Then this acylum ion is the carbocation that can undergo the electrophilic attack on the benzene ring. The second step will be the electrophilic attack on the benzene ring. So we have the benzene ring and we have the electron density, the high electron density because of this ring of electrons. This is going to be attacked by the positively charged electrophile. Don't forget that the arrow goes from the electrons toward the positive ion. And then this will create an intermediate. This intermediate will have a positive charge where this ring of electrons will be broken. And then we added the new group, the acyl group, and the hydrogen is still attached. Then the final step is the restoration of the aromatic system or of the aromatic ring. In this part of the reaction, we have the aluminum, which has the negative charge with the chloride, and this is going to attack this hydrogen, and this is going to abstract this hydrogen, and then the electrons of the carbon hydrogen bond will go back into the ring system, and that will lead to restoration of the aromatic ring, and the final product will be produced, which is going to be the ketone. And then we also have hydrogen chloride, which is this hydrogen with the chloride, and the aluminum chloride, which is the catalyst, will be restored at the end as it is because it's just a catalyst. The second reaction is the nitration. And a nitration is basically adding a nitro group to the benzene ring. To do this, you need to warm a benzene with concentrated nitric acid and sulfuric acid, and that will lead to formation of nitrobenzene. Sulfuric acid will act here as a catalyst. So it will make nitronium ion. Nitronium ion is NO2 plus, which is the electrophile that is going to attack the benzene ring. So the first step is the generation of the electrophile, where nitric acid with sulfuric acid will first produce these two products with H2NO3 plus and HSO4 minus, and then this H2NO3 plus will undergo the breaking down into the nitronium ion, will produce the nitronium ion, which is the electrophilic species, and water. And then we have the nitronium ion in the same way as Friedel-Crafts acylation. There is an electrophilic attack. As you can see, the electrons goes from the ring toward the nitronium ion, and that will break the ring of the electrons with a positive charge inside. And then the hydrogen from the carbon hydrogen bond will be broken, and the electrons of this bond will go inside the ring to restore the ring system or the aromatic ring system or the ring of electrons. And the final product here is going to be the nitrobenzene. And then, of course, we have the hydrogen ion that's going to react with this one again to reduce the sulfuric acid, which is basically just a catalyst. So it has to be restored at the end. Nitration is a very important reaction, and this can undergo several nitration steps, the benzene ring. So in order to keep it to only mono-substituted nitrobenzene, you need to keep the temperature below 55 degrees in order to get the mono-substitutes. Otherwise, if you use higher temperatures, there will be multiple nitrations. You're going to end up with di or tri-nitro compounds. Nitration is a very important reaction which is used in production of several important products like TNT. So TNT is trinitrotoluene or 2,4,6-trinitromethylbenzene. So 2,4,6 trinitromethylbenzene. This is an explosive compound. This is produced by nitration of methylbenzene. So nitration of methylbenzene can add three nitro molecules or three nitro groups to benzene ring, and this is going to be in position 2, 4, and 6 to produce TNT. Also, nitrobenzene can be used to produce aromatic amines. Aromatic amines can be made by reduction of nitrobenzene. So if you have nitrobenzene and this undergo reduction, that will give you the phenyl, the anilines or the aromatic amines. And these aromatic amines are very useful because they are used in the manufacture of dyes and pharmaceuticals.